Assalamualaikum warahmatullahi wabarakatuh. How are you guys? I hope you are doing fine. Today, I want to show you how to implement Cognito OAuth2 implicit with API gateway. So the first of all, why do we authenticate API calls? For security and protection, of course, ensures only authorized access, prevents unauthorized data viewing or modifications, and protects against attacks and breaches. Identity and control verifies user application identity, enable access control and permissions, and also allow usage tracking and rate limiting. Not only that, but it is also need to be compliant trust, meets regulatory standards for data handling, builds user confidence in data protection, enables personalized user experiences. And the last one is for the operational benefits to facilitate analytics and billing, supports fair usage policies, and enhance overall API reliability. This diagram illustrates the flow of a login process involving AWS Cognito and AWS API Gateway, where a user authenticates via Cognito hosted UI and then uses the obtained access token to access an API through API Gateway. So I will explain to you from the user initiates login. The user starts the authentication process by interacting with an application that prompts a login. Then the second one is Cognito redirect to hosted UI. The user is redirected to Cognito's hosted UI, which provides a secure interface for entering login credentials such as email and password. And then the user submit credentials. The user submits their credentials through the hosted UI and Cognito handles the authentication. In this case, user will submit username and password. And then the Cognito will return access and ID tokens. Upon successful authentication, Cognito issues access and ID tokens. These tokens are returned to the user's browser in the URL fragment. Tokens returned directly in URL fragment. This means that the tokens are embedded in the URL, but it is essential to securely handle this data to prevent exposure. And then we call API with access token after receiving the token, but actually it is ID token, not access token. After receiving the tokens, the user or the application calls an API hosted behind an API gateway. The access token is included in the API request to authenticate the user. Then we will validate the token. API gateway forwards the token to Cognito or another validation mechanism to ensure that the token is valid. Confirm the token validity. If the token is valid, API gateway grants access and processes to the user's API request, such as the ID token or access token only may live for 1 hour, and the request token only may valid for 30 days. Return API response. Once the API processes the request, the response is returned to the user. Ensure proper security measures throughout the process. This is reminder emphasize the importance of securing tokens, including how they are handled, transmitted, and stored. This is the components. So first we have an AWS environment, and then we will create an API gateway, and then we will create also Cognito so that the AWS API gateway can use this Cognito as the authorizer. That the backend that I use in this tutorial is Lambda function. This Lambda function only returns hello world. And then this is us, this is the user. So the user will access the public API gateway. Okay, that's all from me. So let's hands on. Okay, so I use Terraform for this tutorial. Let's visit the cognito.tf. This Terraform configuration sets up an Amazon Cognito user pool and related resources, generates a password for a user, and adds a new user to the Cognito user pool. Let's break it down step by step. So the first one is This one, Cognito user pool resource. This block creates a Cognito user pool, which is a managed service for user management and authentication. The name of the user pool is specified using a variable for project name that a user pool stores information about users and enables the authentication and authorization flows. So if you wonder what is the name for this Cognito user pool, you can click this variables.tf and this is the name OAuth2 implicit FA gateway authorizer. So let's get back to cognito.tf, and then the second one is this block. This block defines a Cognito user pool client that allows applications to interact with Cognito user pool. Let's break down the important parameters. So the first one is name. Use the project name as the client name. User pool ID. This links the client to the Cognito user pool created earlier. Allow OAuth flows specifies the type of OAuth flow allowed for this client. In this case, it uses implicit flow, which is typically used for browser-based client where tokens are returned directly without an authorization code. And then allowed OAuth flows user pool client enables OAuth 2.0 for this client. Allowed OAuth scopes defines the allowed OAuth scopes, specifies the OAuth scopes allowed for this client. In this case, the email, OpenID, and profile scopes. Callback URLs specifies where users should be redirected after authenticating. In this case, the URL for the Postman OAuth callback. Logout URLs defines where the users will be redirected after logging out. Here, Postman's logout URL. Supported identity providers. The only identity provider supported for this client is Cognito, meaning users can log in using Cognito's built-in authentication mechanism. And this one, generate secret. Setting generate secret to false means that this client does not need a secret. Public clients, like single-page applications, typically do not require secrets because they cannot securely store one. Okay, let's continue to the next block. Cognito user pool domain resource. This block creates a Cognito user pool domain, which allow your users to access a hosted login page provided by Cognito, of course, where they can log in and perform other authentication actions. Domain, this one. A custom domain is created based on the value of var.project_name. User pool ID, this links the domain to the previously created user pool. The domain allows users to authenticate against the user pool using the hosted login UI provided by Amazon Cognito. The next one is random password generator. This block generates a random password for a user that will be added to the Cognito user pool. These passwords meet specific criteria. First is the length. The password will be 12 characters long. Second one is special. The password will include special characters. The third one is numeric. The password will contain numeric digits. And the fourth one is lower. The password will include lowercase letters. This password will be used when creating a user in the Cognito user pool. The next one is this block, adding a user to Cognito user pool. This block uses a null resource to run a custom command that adds a user to the Cognito user pool. This command runs via the local exec provisioner, this one, which executes shell commands on the local machine. The command creates a user using AWS CLI admin create user command, this one. For the user pool ID, specifies the ID of the user pool where the user will be created using the pool ID from AWS Cognito user pool.pool. Username, sets the username to herley@mailinator.com. So we will see of this implementation. User attributes adds two attributes the user email herley@mailinator.com and verifies that the email is valid. Email underscore verified equal true, and temporary password uses the random password generated earlier for this user. The last one is desired delivery medium specifies that the password will be delivered via email. The depends on parameter ensure that the user pool and the random password are created before this command is executed. So, and then for the last one, I output the generated password. This blocks outputs the generated random passwords. Since the password is sensitive information, it is marked as sensitive equal true, meaning it will not be displayed in the plain text when Terraform runs unless explicitly requested. Okay, we're done for Cognito.tf. So let's take a look API gateway.tf. This Terraform configuration effectively sets up an API gateway REST API integrated with a Lambda function and secured via Cognito authorizers. Here's the breakdown of the resources defined and how they work together. So the first one is API gateway REST API main. The AWS API gateway REST API resource defines the API itself using the project name from variables. The second one is the Cognito authorizer. The AWS API Gateway Authorizer resource configures Cognito user pool authorization for the API gateway. Provider ARNs refers to the Cognito user pool ARN, enforcing the use of that pool for authentication. So the next is API Gateway Resource. The AWS API Gateway Resource defines the path, this one /serve for the API. Parent underscore ID use the root resource ID of the API. And the next one is API gateway method. The AWS API gateway method resource configures a post method on the /serve path. This one, post. Cognito user pool authentication is enforced for this method using the previously defined authorizer. And then we also need the Lambda integration because I want to use Lambda function as my backend. So this block, I mean, the AWS API Gateway integration resource sets up integration with the Lambda function. The API Gateway will act as a proxy to invoke the Lambda function via its ARN. And the next one is the Lambda permission. This AWS Lambda permission resource grants the API Gateway permission to invoke Lambda function. So we give the permission to the AWS API Gateway to execute this Lambda function, Lambda invoke function. Okay, the AWS API Gateway deployment, this block deploys the API Gateway setup. The create before destroy, this one. This is a life cycle which rule ensures smooth update during the changes. And the next one is the AWS API Gateway stage. This block defines a stage dev, this one, for the API deployment. Okay, now let's take a look our Lambda function. So the first one, I need to create the Lambda function using Terraform. And here we go. This one, resource AWS IAM role, Lambda role, defines IAM role with a trust relationship that allows Lambda to assume the role, this one. And then the second one is local file for Lambda functions, data, local file, Lambda underscore function.py. The file is here, Lambda underscore function.py. You need to make sure that this file is exists. Otherwise, you cannot create the Lambda function because it is referring to this file. Next, this block, zip command with null resource, null resource. This resource runs a local zip command to package the Lambda function code. And then last one is AWS Lambda function deployment. This defines the Lambda function and upload the zip files. So I also define the text in here, and I also define the runtime. I use Python 3.12, and the handler, you need to make sure that this is the same with what is inside the Lambda function. So this is actually the inside of this tutorial Lambda function, just a simple Lambda handler event context, log something from event, then you return status code body hello world. And then this is the function name, and the resource is coming from lambda function.zip. And okay, I think we're good to go. Before we go, pay attention to this line, because this line actually remove lambda function.zip if it were exist. But if it does not exist, then this command will create the lambda function zip using this data resource. Okay, so let's try. Okay, so Terraform validate and Terraform empty recursive. This command will format this code. Okay, nice. So let's apply Terraform, apply auto, hit enter. Wait for a moment. Okay, creation is complete. Alhamdulillah. So let's see in the AWS console. This is the Amazon Cognito console. It's empty, but if I refresh this, now we have created the Amazon Cognito user pools. The same with Amazon API Gateway. It's empty, but if we refresh this page, now Alhamdulillah, we already created the OAuth implicit API Gateway authorizer for this API Gateway. So let's go back to Amazon Cognito, and then click this user pool. Then you can see here that the user's Herley at Melinator is already registered, and we force this user to change the password. Now, okay, let's check the email. I use the Melinator. So this is the username, and this is the temporary password. We will use this later. Okay, I think it is good. So let's click the app in integration and click this, and then we right click this and then copy this link. Okay, let's head to Amazon API Gateway. Click this, and if you click the authorizers, you will see that you are already using the OAuth2 implicit API Gateway using Cognito. So the Cognito is chosen instead of AWS Lambda function. Now let's call this API from Postman. Okay, so this is the Postman. I need to change this URL with the previously copied code. By the way, you need to choose this tab, authorization, and you choose the auth type or OAuth 2.0, and then you need to choose the grant type is implicit. We have a lot of choice, but in this tutorial, I use implicit. Okay, I think it's good. Now you click get new access token. Now, we will use the username and password that previously sent to Mailinator. So this is the username. and this is the password. Okay, sign in, not now, and then we need to use a new password, and let's set this up because previously we want to enforce the user to use a new password. The token name, I want to use sample and use token. Okay, token added. Alhamdulillah, we are already succeeded to sign in to Amazon Cognito. Scroll up, and then instead of choosing access token, you choose ID token in here. So let's hit the API. Go to the stage, dev, and this point, serve. Then you copy this invoke URL. Go back to Postman, paste here, and then try to hit it. Hello world. This is the response from the Lambda function. Okay, after you try this, and then Alhamdulillah, we find that this is succeed, respond 200 okay. Don't forget to destroy all of your resources. So to destroy the resources, just type Terraform destroy auto approve. Okay, that's all. Thank you for watching. Have a good day. Wassalamualaikum warahmatullahi wabarakatuh.